Now we are going to continue the problems regarding the system of particles and rotational motion. Part 1. Already we have done the theory. Center of mass of the system, what is called angular momentum, angular acceleration, angular velocity, torque, and the relation between torque and angular acceleration, relation between torque and angular momentum. All these things we have seen. Now we are going to see the related problems. First problem, the separation between C and O atoms in CO is 1.2 Armstrong unit. What is the distance of carbon atom from the center? Center of mass related. Here, this is C, this is O. The distance between them is given as 1.2 Armstrong unit. You have to calculate the center of mass from carbon atom, that is from the origin in our example. Center of mass basic formula m1x1 plus m2x2 whole divided by m1 plus m2. That is center of mass distance is carbon is 6C12, oxygen is 8O16. So in terms of atomic mass unit only, we are representing the mass 12 AMU, 16 AMU. That is the mass. So I can write 12 into, since it is starting with the origin, the distance is 0, plus 16 into the distance x2 is nothing but 1.2 Armstrong unit. Final answer also we'll write in Armstrong unit, so we will write 1.2. Actually, we have to put 1.2 into 10 power minus 10. But final answer also we are going to express in Armstrong unit. Divided by m1 plus m2, that is 12 plus 16. 16 into 1.2 by 28. You simplify this, you are getting 0.687 Armstrong unit. So from the carbon atom, the center of mass is situated at a distance of 0.687 Armstrong. Simple. First problem. Second, 2-point masses 3 kilogram and 5 kilogram are at 4 meter and 8 meter from the origin on x-axis. Locate the position of center of mass of 2-point masses, 1 from the origin and 2 from 3 kilogram mass. Say this is the basic diagram. This is the origin. 3 kilogram mass is situated here. 5 kilogram mass is situated at some other point. This is 3 kilogram. This is 5 kilogram. The distance from the origin given, what is the value? 4 meters. So x1 is equal to 4 meters. 5 kg mass is situated at a distance of 8 meters. So x2 is equal to 8 meters. You have to calculate center of mass position. So here is the center of mass point. Then we will take this distance as xcm. xcm is the center of mass distance from the origin. Here is a center of mass means x. That we are going to calculate. 1 xcm from the origin. What is the value? What is the formula? m1 x1 plus m2 x2 whole divided by m1 plus m1. What is m1 ma? 3. The distance is 4 meters plus second mass is 5 kilogram. The distance is 8 meters divided by 3 plus 5. So 12 plus 40 by 8. 52 by 8. X center of mass is 52 by 8. That is 6.5 meters. So from the center, from the origin, the center of mass is situated at a distance of 6.5 meters. Second case, from 3 kilogram mass they are asking for. This point they are asking. Actually, 8 minus 4, 4 directly we can write that, but we should not do like that. 3 kilogram mass. So take that value as origin. So here we have to take it as origin. You cannot calculate total value is 8 meters. Subtract the center of mass distance 6.5, remaining 1.5, like that and all. So we cannot do like that. So 3 kg mass is situated here. 5 kg mass is situated here. What is the distance? X dash cm. This is 4 meters, ma. This is 4 meters. Center of mass is here. So take this as x dash cm. That x dash cm only we have to calculate. Same formula, no change at all. What is formula? X dash cm is m1 x1. M1 is 3. Since 3 kilogram is at the origin, so we can write 0 plus 5 kilogram is situated at a distance of 4 meters divided by 3 plus 5. So I can write 0 plus 20 by 8. So 20 by 8, 20 by 8 is 2.5 meters. 2.5 meters. Simple. Correct? Center of mass, we have done 2 problems. Next, we are going to talk about torque. Problem related to torque. Find the torque of the force 7I minus 3J minus 5K about the origin, which acts on a particle whose position vector is R is equal to I plus J minus K. Force F, third problem, given force F is equal to 7I minus 3J minus 5K. R vector is I plus J minus K. Calculate the torque. What is torque formula? R cross F. So we have to write IJK. IJK. 1 minus 1. R cross F. Magnitude 1 minus 1. F magnitude 7 minus 3 minus 5. So torque is I cap cross multiply This column, this row, you leave it, cross product. This one minus, so minus 5, minus 3, minus 1 is 3, but minus only opposite, minus 3. Minus j into, leave this column and this row, 1 into minus 5. 7 into minus 1 is minus 7, but it is minus of the second. So plus 7. Plus k into this column, this row you leave it, minus 3, minus 7. So we can write minus 3, minus 5, that is minus 8. Minus 8 I cap, minus 5 plus 7, that is 2. Outside we have minus, so we have to put minus 2j, minus 3, minus 7, that is minus 10k. This is torque. Right? Third problem related with the torque. Fourth one, moment of inertia of the body we have to calculate. Torque 2 into 10 power minus 4 Newton meter is applied to produce angular acceleration 4 radian per second square in a rotating body. What is the moment of inertia of the body? We know the relation between torque and angular acceleration. Torque is I alpha, where I is moment of inertia, alpha is the angular acceleration, tau is the torque. What is asked here? Moment of inertia is asked. Tau is equal to, sorry, I is equal to tau by alpha. What is tau given, man? 2 into 10 power minus 4 Newton meter by alpha value 4 radian per second square. So I can write 2 by 4, 1 by 2.5, 10 power minus 4 kilogram meter square. Kilogram meter square. That is moment of inertia of the body. Straight problem. Torque with moment of inertia and angular acceleration. One more formula we have seen, torque is R cross F. Fourth problem related with the torque and the moment of inertia with angular acceleration. Third problem, torque related with force and displacement, R cross F. Both we have seen. Okay. Next, the angular momentum of a body is 31.4 joules second and its rate of revolution is 10 cycle per second. Calculate the moment of inertia about the axis of rotation. Problem number 5. Angular momentum of a body given. What is angular momentum formula? Angular momentum represented by L, that is I omega. I into omega is 2 pi nu. Question is I to be calculated. So L by 2 pi nu. What is L, ma? 31.4 by 2 pi into rate of revolution is 10 cycle per second. So nu is called a frequency. Frequency 1 by time period, both are same. That value given, that is 10 cycle per second. 10. 31.4. Pi is 3.14. 31.4 means 10 times. 10 cancels. 1 by 2 is 0.5 kilogram meter square. Simple. Straight. Sixth one. A disc initially at rest starts rotating about its own axis with a constant angular acceleration 0.2 radian per second square. What is the time taken by the disk to rotate 10 radians? Given angular acceleration, theta value given, then you have to calculate the time taken. Okay. Equations of rotational motion we have seen. Three equations we have. Omega is equal to omega naught plus alpha t. Theta is equal to, that is equivalent to S is equal to ut plus half at square. So theta is equal to omega naught into t plus alpha half alpha t square. This initially at rest. That means omega naught is 0. Initially at rest. Omega naught 0. Okay, then theta is equal to half alpha t square. T square is 2 theta by alpha. 2 into theta is 10. 2 into 10 by alpha value given as 0.2. 0.22 means 10 times. This is t square 100. So t will be 10 seconds. T will be 10 seconds. Straight problem. Sixth one. Seventh problem. A car moving at a speed of 72 km per hour. The diameter of its wheels is 0.5 meter. If the wheels are stopped in 20 rotations by applying brakes, calculate the angular rotation produced by the brake. Okay. So here also we are going to use equations of motion. Car is moving at a speed of 72 km per hour. So first you convert into meter per second. 72 km per hour into meter per second is 72 into pi by 18. 1 kilometer is 1000 meter. 1 hour is 3600 seconds. So 72 into 1000 by 3600 is a simplify 5 by 18. So 4 times. So I can write V naught is 20 meters per second. 20 meters per second. Next, V is equal to R omega. So omega is equal to V by R. Basic formula. This is V naught. So omega naught. V naught by R. What is V naught? 20. Diameter of the wheel is 0.25. This R is nothing but radius. So we have to put 0.25. 0.25 is 1 by 4. So you will get 80 radian per second. What is theta given? 20 rotations. Stopped in 20 rotations. One rotation means 360 degrees. That is 2 pi. 20 rotations. Theta is equal to 20 into 2 pi. So what is the formula? Omega square is equal to omega naught square plus 2 alpha theta. V square is equal to U square plus 2AS. Basic formula. For rotational motion, V is replaced by omega. So omega square is equal to omega naught square plus 2 alpha theta. Omega square Wheels are stopped. That means final angular velocity is 0 is equal to omega naught square. What is omega naught square? 80 square plus 2 into alpha only you are going to calculate. Alpha, theta value 45. So 80 pi alpha is equal to, this is 80 pi alpha is equal to minus 80 square. 180 get cancelled. So alpha is equal to minus 80 by pi, minus 80 by 3.14, minus 25.5 radian per second square. Why minus there? Stopped. In the case of linear motion, we call this one as deceleration, negative acceleration. So rotational motion also negative angular acceleration. So we are getting the answer in negative. Okay. Next, eighth problem. Again, torque. Find the torque of a force. F is equal to minus 3I plus J plus 5K. R is 7I plus 3J plus 3 plus K. Calculate the torque. F is minus 3I plus J plus 5K. R value 7I plus 3J plus K. Therefore, torque is R cross F. Basic formula R cross F. Already we have seen this R cross F by determinant method. That is, torque is equal to I J K. Magnitude 7, 3, 1 for R, minus 3, 1, 5 for F. So torque is equal to I into this column, this row you leave it, cross multiply. 3 into 5 minus 1 into 1. 3 into 5 minus 1 into 1. Minus J. This column, this row. 7 into 5 minus 3 into 1. 2 minus, so it will become plus. Plus K into this column, this row you leave it. 7 no ma, 7 into 5, 35. Then minus 3 into 1. Already 1 minus, so it will become plus. Plus 3. Then 7 minus of minus 9 plus 9. So I can write tau is 15 minus 1, 14I, 35 plus 3, minus 38J plus 16K. 14I minus 38J plus 16K. That is the final torque. Next, problem number 9. Moment of inertia of a body is 1 kilogram meter square. If the body makes 2 revolutions per second, calculate the angular momentum. Angular momentum formula you know. L is equal to I omega. I into omega is 2 pi nu. What is moment of inertia given? 1 into 2 pi into nu. What is the number of revolution? 2 revolutions. So answer is 4 pi radian per second. Radian per second into kilogram meter square. So joules second you will get. I omega, kilogram meter square, radian per second. Combined, you will get joules second. Straight simple problem related to angular momentum. Ninth problem. 10th one. Constant torque 31.4 Newton meter is exerted on a pivoted wheel. Calculate the moment of inertia of the wheel if angular acceleration of the wheel is 4 pi radian per second square. Torque is given, angular acceleration is given, moment of inertia we have to calculate. So, formula for 10th one, torque tau is equal to I alpha. Straight problem. I is tau by alpha. What is tau? 31.4. Alpha value 4 pi. Pi is 3.14. 3.14 and 31.4 is 10 times. 10 by 4 is 2.5 kilogram meter square. Moment of inertia for the 10th problem. Straight. Next, torque of 10 Newton meter applied to a flywheel of mass 10 kilogram, radius of gyration 50 centimeter. What is the resulting angular acceleration? Tau is equal to I alpha. You know very well, I is mk square. Moment of inertia basic formula mk square, where k is called radius of gyration into alpha. What is to be calculated? Alpha to be calculated. So alpha is torque by mk square. What is torque? 10. Mass is 10 kilogram. Radius of gyration is 50 centimeter. That is 0.5 meter. K square. So calculate 10, 10 cancels. This is 0.25. 0.25 is 1 by 4. So 4 will go to numerator. Answer is 4 radian per second square. Straight. 12th one. A grindstone has a moment of inertia 6 kilogram meter square. Constant torque is applied and the grindstone is found to have a speed of 150 rotation per minute. 10 seconds after starting from rest. Calculate the torque. Number of rotation 150 rotation per minute. So 150 by 60. 15 by 6 is 5 by 2. That is 2.5 rotation per second. Next, omega. Omega is 2 pi nu. 2 pi into 2.5. So 5 pi radian per second. 5 pi radian per second. Next, alpha we have to calculate. Omega is equal to omega naught plus alpha t. 3 equations of rotational motion. First equation, omega is equal to omega naught plus alpha t. So alpha is equal to omega minus omega naught by t. What is omega? 5 pi minus initial starting from rest after 10 seconds. So what is omega naught, ma? Constant torque is applied to have a speed of 150 revolution per minute 10 seconds after starting from rest. Calculate the term. So in this case, omega minus omega naught by t. Question is starting from rest. Starting from rest means omega naught is 0. So pi by 10 is 1 by 2, pi by 2. Alpha is pi by 2. Question is torque. So torque is I alpha. What is moment of inertia given? 6. This is pi by 2. 6 into pi by 6 pi by 2 is the answer. That is 3 pi Newton meter. 3 pi Newton meter. Six pi by 2, that is 3 pi Newton. Torque unit. Take from. Correct? First you have to calculate the frequency, then omega, then alpha. Three things. Frequency is given, but it is given per minute. That you have to calculate per second. So we are changing. Correct, Rama? So these are the problems related with torque, angular acceleration, moment of inertia, angular momentum, and the center of mass. This is the first part of system of particles and rotational motion related problems. Next, we are going to see moment of inertia of a disk, ring, sphere, all these things, related problems. Thank you.